Hi, and welcome to AR Maths Pro Learning Academy. In this video, I'm going to talk about relations and functions of Class 12, Chapter 1, Exercise 1.2, Explanation and Solutions, Part 2, from questions 5 till 12. Question 5. Show that the signum function f from R to R given by f of x is equal 1 if x is greater than 0. It is equal 0 if x is 0. It is equal negative 1 if x is less than 0. It is neither 1, 1 nor onto. At first, draw a rough diagram so that you get more idea. From domain is my all real numbers and range is also, codomain is also all real numbers. So I just consider few numbers with negative, 0 and positive. Now, if you see this diagram, all negative numbers, which means less than 0, gives the result as negative 1. So many elements of domain gives one range. So if you see many elements giving one image, one single image, that means the given function is not 1, 1. As well as if you see the negative elements of codomain do not have any pre-image in domain, so it is not onto as well. Let us prove it. Let us write it. Okay, for 1, 1 function. Okay, let us consider any two elements which belongs to domain. I consider two elements as negative 1 and negative 2, which belongs to domain, such that f of negative 1 is equal f of negative 2. F of negative 1, which means x is less than 1, the result is negative 1. And f of negative 2, which is also less than, x is less than 0, which gives the result negative 1. So both of them are negative 1. So negative 1 is equal negative 1. But x is not equal to y. This is the condition, no? X must be equal to y, then only we can say the given function is 1, 1. But here x is not equal to y. Negative 1 is not equal to negative 2. So the given function is not 1, 1. Let us go for onto function. If you see all negative values and all positive values more than 1 and do not, from codomain, do not have any pre-image in its domain. So it is not onto as well. Give one example. See, negative 2, which belongs to codomain, and negative 2 do not have any pre-image in its domain. So the given function is not onto. You can write a general statement instead of this one. There exists y belongs to codomain and has no pre-image in its domain under the function f of x. Therefore, the given function is not onto. Question 6. Let A set of elements is 1, 2, 3 and B has set of elements 4, 5, 6, 7. And function is defined as 1, 4, 2, 5, 3, 6. Be a function from A to B. Show that f is 1, 1. Just draw a diagram. Set A has 3 elements, A 1, 2, 3, and set B has 4 elements, 4, 5, 6. To check for 1, 1 condition, we just need to check the elements of set A. Each element has unique and distinct images in codomain. Check 1 has 4, 2 has 5, and 3 has 6. So the given function is 1, 1. But if you see, it is not an onto function because the element of set B, codomain, do not have any pre-image in its domain. That is why it is not onto function, but it is a 1, 1 function. Question 7. In each of the following cases, state whether the function is 1, 1, onto or bijective. Justify your answer. The first question. Function f from real numbers to real numbers defined by f of x is equal to 3 minus 4x. Let us draw a rough diagram. Any real numbers. I just choose any real numbers, random. Okay. These are x values. If I plug in here in the given function, I am getting some image in codomain. Like this, if I plug in any values from the domain, I'm getting a image. So each element has its own, a unique and distinct image in codomain. So the given function is 1, 1. Let us prove it. Given function from R to R defined by 3 minus 4x for 1, 1 function. For 1, 1 function, x comma y belongs to domain such that f of x is equal f of y. Now, what is f of x? 3 minus 4x. And f of y? 3 minus 4y. It should be like this. Now, I'm going to keep it. So, this 3 and this 3 I can get cancelled. And negative 4x is equal to negative 4y. And this negative 4 and this negative 4 gets cancelled. So, x is equal y. If x is equal to y, that means the given function is 1, 1. Now, we have to check for onto function. How can I check for onto function? Onto function is nothing but a reverse order. You need to check from codomain to domain. What is the given function? Y is equal 3 minus 4x. This is the given function. Now, from this given function, solve for x. Solve for x means you have to write in terms of y. If I switch 3 on the other side, it becomes negative 3. Okay. Sorry, I switch this negative 4x to become its positive and this y over here, which becomes negative y. So 4x is equal to 3 minus y. Only x is equal 3 minus y divided by 4. This is solved for x in terms of y. Now plug in any values from codomain, here, okay, in place of y. I will get an x value. If I plug in any values, for example, if I plug in x as 1, so 3 minus 1 over 2, which is nothing but 2 over 2, 1. I got a pre-image. So like this, if I plug in any positive, negative, decimal, fraction, any values here in y, I'm getting a pre-image. That means the given function is onto. How can we write it? We write like this. For all or for any y belongs to codomain, there exists, of course, there must be something, some pre-image. There exists an x belongs to R under the function f of x is equal 3 minus 4x. Therefore, the given function is onto. Now, the given function is 1, 1 and onto. If the given function is both 1, 1 and onto, then it is a bijective function. Part 2 of question 7. Given function from R to R defined by f of x is equal 1 plus x square. Always draw a rough diagram. Any values of real numbers. You can take decimal, you can take fraction, anything. So I took some values and I'm going to plug in here in place of x. So definitely I am getting a answer. But if I plug in as negative 2, I got positive 5. Here, check. If I plug in 2, I got positive 5. Now, two elements of set A or of domain has one image. If two elements has one image, that means it is not a 1, 1 function. Let us prove it. Okay, let us prove it. For 1, 1 function, let x comma y belongs to domain such that f of x is equal f of y. Now, what is f of x? 1 plus x square. And what is f of y? 1 plus y square. So 1 plus x square is equal 1 plus y square. So this plus 1 gets cancelled, because if I switch 1 to the other side, it becomes negative, so it becomes 0. So x square is equal y square. Remember this note. If I have even powers, Okay, then x is not equal y if x and y belongs to range. Belongs to real numbers. If it is belongs to real number, they are not equal. If they belongs to integers, they are not equal. If they belongs to natural numbers, yes, they are equal. For even numbers, okay, for even powers. So here x is not equal y. If x is not equal y, which means the given function is not 1 1. The given function is not 1 1. Let us check for onto function. Onto function, what is the given function? First of all, given function f of x is equal 1 plus x square. So this x square, the meaning of x square is the result lies in between 0 to infinity. Why I'm saying x square lies between 0 to infinity? Because if I plug in any values, any negative values of x, I am getting positive. So if I plug in 0, I'm getting 0. If I plug in negative 1, I'm getting 1. If I plug in negative 2, I'm getting 4. So the x square values lies in between 0 till positive infinity. Now add 1 throughout the inequality. So if I add 1 throughout the inequality, 1 plus 0 is 1 and 1 plus x square less than 1 plus infinity is nothing but infinity. That means this function, this is our function f of x. So f of x lies in between 1, positive 1 till infinity. This contradicts with our question because the function says from real numbers to real numbers, but the function lies in between from 1 to infinity. So this is my range. The range lies in between 1 till infinity, from 1 till infinity, whereas the range, the codomain, so this is my range which lies from 1 till infinity, but my codomain is all real numbers. So codomain, try to remember, codomain means all possible outcomes. Range means actual outcomes. This is the difference between codomain and range. So here range is not same as codomain. If they are not same, then the given function is not onto. Question 8. Let a and b are sets. Show that the function a cross b to b cross a, Cartesian product, such that f of a comma b is equal b comma a is a bijective function, which means this given function is 1 1 and onto, because we have to show that a function is a bijective function. Let us prove it. Okay, for 1 1 function, let x comma y belongs to a cross b such that f of x is equal to f of y. F of x is nothing but f of a1 comma b1, which is equal to f of a2 comma b2, where x belongs to a1 comma b1 and y belongs to a2 comma b2. F of a1 comma b1, the definition says f of a comma b is equal b comma a. So it is b1 comma a1. F of a2 comma b2 is nothing but b2 comma a1, as per the definition of the function. So if you see carefully, b1 is equal b2 and a1 is equal a2. So if a1 is equal a2 and b1 is equal to b2, which means a1 comma a2 is equal b1 comma b2. If they are equal, which means this is x and this is y. This means x is equal y. If you prove x is equal y, which means the given function is 1 1. Now check for onto function. Let us draw a rough figure for this one. A cross b has an element a comma b, which gives the result b comma a. So any values, like if I keep x comma y, f of x comma y, then I'm getting y comma x. So this has a preimage. So every element of set B codomain has a preimage in its domain. Therefore, there exists for all y belongs to b comma a, which is a codomain, there exists x belongs to a, which is a domain, under the function f of a comma b is equal to b comma a. Therefore, the given function is on 2. If a function is 1, 1 and on 2, that means the given function is a bijective function. Question 9. Let a function from n to n, natural numbers through natural numbers, be defined by f of n is equal to n plus 1 over 2 if n is odd, n over 2 if n is even, for all n belongs to n. State whether the function f is bijective. Justify your answer. The first thing, draw a rough graph. The first thing, n means natural numbers, which starts from 1 till infinity. So if I plug in 1 is odd, so I'm gonna keep it here. 1 plus 1 will be 2. 2 over 2, that gives result 1. If I plug even, which is 2, here I have to plug in here, okay? So 2 over 2 is nothing but 1. So two elements of domain gives one image in its codomain. So the given function is not 1, 1 function. Let us prove it. For 1, 1 function, let any two elements 1, 2 belongs to domain such that f of 1 is equal to f of 2. F of 1, which means I'm going to use this definition because 1 is odd, and f of 2 I'm going to use n over 2 because n is even 2. So if I plug in x as 1 in this one, x as 1 in this one, I got 1 plus 1 over 2, I got 2 over 2, which means 1. And if I plug in x as 2, which is an even, n as 2, which is an even here, so 2 over 2 will be 1. So here 1 is equal 1, but x is not equal y because 1 is not equal to x is not equal y. If it is x is not equal y, that means the given function is not 1, 1. If x is not 1, 1, then I have to go for on2 function. How can I prove it? That check, if you see all the elements of codomain has a preimage, 1 or 2. Each element has some preimage in its domain. All the elements like this, if you go through till the infinity, you will have some preimage. So the given function is on 2. For all y belongs to codomain, there exists an x belongs to domain under the function f of n. Therefore, the given function is on 2. Question 10. Let set A equal all real numbers except 3 and set B equal all real numbers except 1. Consider the function from A to B defined by f of x is equal x minus 2 over x minus 3. Is f 1, 1 or on 2? So we have to check the given function is 1, 1 or on 2. This is the given this is the given function f of x, and from A to B, and A belongs to all real numbers except 3 and B belongs to all real numbers except 1. For 1, 1 function, let x comma y belongs to all real numbers. I wrote natural numbers. X comma y belongs to all real numbers such that f of x is equal f of y. F of x is nothing but x minus 2 over x minus 3, and f of y is nothing but in place of x you write y minus 2 over y minus 3. So in place of x, f of x, I wrote x minus 2 over x minus 3, and in place of f of y, I wrote y minus 2 over y minus 3. By cross multiplying, x minus 2 times x minus y minus 3 and y minus 2 times x minus 3. So each and every element multiply with each other like this and like this, like this and like this. If I multiplied it, I got it like this. Check, x multiplied by y, xy, x multiplied by negative 3, negative 3x, negative 2 multiplied by y, negative 2y, negative 2 multiplied by negative 3, it's positive 6. Like this I multiplied on the right side as well. Now the next question, 6, positive 6 and negative 6 I can cross out. And what can I cross out? Xy and xy, positive xy, positive xy, because if I switch the terms, it cross outs. One will become positive, another will become negative, so it becomes 0. This is the remaining part, negative 3x, positive 2y. I switch this negative 2x on the left and negative 2y on the right. So I got like this. So negative 3x plus positive 2x, which is negative 1x, which is equal to negative 1y. Negative negative cancels. I got x is equal y. If I get x is equal y, which means the given function is 1, 1. Now check whether the given function is onto or not. First of all, given function y is equal x minus 2 over x minus 3. Solve it in terms of x. So I just cross multiply this. Okay, so it will be like this, y times x minus 3 equal x minus 2. And the next step, y, I will open the parenthesis, y times x and y times 3 will be xy minus 3y. And then I switch the terms, y, x on one side, y on the other side, like this. So xy minus x. So in this term I can take x as common. If x is common, it will be remaining y minus 1. Check, if you multiply x times y, xy, x times 1, negative x. Now I need x, solve for x, no? So I don't need this term, so it goes to the denominator. So x is equal 3y minus 2 over y minus 1. And here x is not equal 1, which is set B says all real numbers except 1. So if I plug in all values of x, all real numbers of y, I am getting something in x, something in domain, which is x, which means all codomain values, okay, has a pre-image in its domain. So this is y. So if I plug in any values, any real numbers, negative 3, negative 2.5, any values, or positive 3 or positive 2.5, any values, if I plug in here, plug in place of x, in place of y, I am getting a pre-image. Therefore, for all or for any y belongs to codomain, there exists an x belongs to domain under the function f of x is equal x minus 2 over x minus 3. So the given function is onto. Remember, if a function is 1, 1 and onto, that means it is a bijective function. Question 11. Let function f from R to R, real numbers to real numbers, defined by f of x is equal x power 4. Choose the correct answer, A, B or C, D. Let us draw a rough graph to get better idea. From real numbers, you can choose any real numbers. I just put integers, but you can put any real numbers, including decimal, fraction or anything. All numbers on the line are real numbers. So if I plug in x as negative 2, so or negative 1 in the given function here, okay, if I plug in this negative 1 here, I'm getting the result as 1. Same as if I plug in 1, then I'm getting here in the given function, I'm getting 1. So if two elements of domain has same image in its codomain, then it is not a 1, 1 function. Let us prove it. Okay, let us prove it. This is the given function f of x is equal x square from R to R. For any x comma y belongs to real numbers, sorry, my mistake, I wrote natural numbers. any real number, okay, such that f of x is equal f of y. F of x is x power 4, f of y is y power 4. F of x power 4 equal y power 4. Keep remember the note, okay? If the power is even and xy belongs to a real number, then x is not equal y. So if x is not equal y, that means the given function is not 1, 1. Check it for onto function. Before checking for the onto function, if you see the diagram again, I'm not getting any pre-images of negative values, negative elements of codomain. Because if I plug in all negative values in the given function, x square, I'm getting a positive value. So negative values do not have any pre-image in its domain. So the given function is not onto as well. Let us check. Let us write. Let us check. X power 4 lies in between 0 till infinity because the power is 4. If I plug in any negative values, it gets 0 or more, not less than 0. So the given function, this is x power 4 is the function value. So this is the definition of the function. So f of x lies in between 0 till infinity, which means my range is in between 0 till infinity. But my codomain is all real numbers. So range is not equal codomain. If the range is not equal codomain, that means the given function is not onto. So the answer is option D. Question 12. Let function f from R to R, real numbers to real numbers, be defined as f of x is equal to 3x. Choose the correct answer, A, B, C, or D. Okay. Let us draw a rough diagram and then decide whether the given function is 1, 1 or an onto. From real numbers to real numbers. So if I have any real number and I plug in here, I am getting an image. So if I plug in -1, I'm getting -3. If I plug in 0, I got 0. If I plug in 1, I got 3. If I plug in 2, I'm getting something, 6, something like this. So each element of the domain has a unique and different image in its codomain. So the given function is 1, 1. Let us prove it. This is the given function, f of x is equal to 3x. For any x comma y belongs to real numbers, by mistake I wrote natural number, such that f of x is equal f of y. Here the function f of x is defined as 3x, which is equal to 3y. 3x is equal to 3y. Here 3 gets cancelled. So x is equal y. If x is equal y, that means the given function is 1, 1. Check for onto function. There are many different ways to find onto function. Given function y, this f of x is equal 3x. And x could be any real number. So 3x lies in between -infinity to +infinity because x is any real number. If I plug in any value of x, I will get the answer from -infinity to +infinity. Any real number. So the given function lies from -infinity to +infinity. So the range is all real numbers. If the range is all real numbers and the codomain is also all real numbers, that means the given function is onto. This is the end of exercise 1.2 of chapter 1, relations and functions. If you have learned something new today, hit the like button, share with your friends and family, and don't forget to subscribe. Thank you.